New chapter 6-1 perpendicular and angle bisectors. We've done bisectors multiple times before, so this won't be totally new information, but just a little bit of just a new look to it. So if I've got a segment and I have a perpendicular bisector, I'm going to do my best to eyeball this. That one's way off. That's pretty good. Okay, I've got a perpendicular bisector. What that means is, first off, it's going to create a right angle. And then second, it's going to split this into two equal pieces. Okay, so it's got two different requirements. It must create a 90-degree angle to be a perpendicular bisector. And it also creates two equal segments. Now, some of you might notice where this might be going. Maybe they make some triangles out of these things. And so we've actually already seen these in the last chapter just a little bit. And maybe they ask you what is congruent, which pieces are congruent to which pieces. I mean, really, if we put information here, we've got two different triangles right there. I already see a way we could make this, we could make these two triangles congruent because BD would equal BD, and then we have side angle side for both of them. So there's multiple different questions they could ask, but this would be a common one. So when we look at an angle bisector, we might have something like that, and then we could bisect this angle. And so let's say, let's call this A, B, C. We'll call this D. And so if angle ABC is equal to, let's just make it 70 degrees, and ray BD is a bisector, the way I've drawn it, then that would make angle ABD congruent to angle CBD, and it would make them both equal to 35 degrees. And so we're doing a lot of things there. So the whole thing, ABC, is 70. We cut it in half. Each piece is 35. And it also makes those two pieces congruent to each other. Okay, so let's look at one more thing. Oop, there we go. If I have the coordinates -2, 0, and 6, 12. -2, 0. And I wanted to write an equation of the perpendicular bisector of the segment with the given endpoints. We have to recall that anything that's going to be perpendicular to this line is going to have a negative reciprocal slope. So I'm going to go ahead and graph this real quick. And since it was 12, I'm going to go ahead and go up to 12. And so as I graph those, -2, 0, 6, 12, -2, 0, and 6, 12. Okay, so I would go create that line. And so if I'm going to make a perpendicular bisector, I need to know the midpoint of that line first. So I'm going to take those two coordinates, -2, 0, and what is that again, 6, 12. And I'm going to put them in the midpoint formula. I'm going to find the midpoint. You can probably look and see where it's going to end up, but we want to get it exact. So we're going to add the x coordinates and divide by 2. And we're going to add the y coordinates and divide by 2. And so that's going to give me -2 plus 6. That's going to be 4 divided by 2, which is 2, and 12 divided by 2, which is 6. So my midpoint is 2, 6, which is kind of where I eyeballed it. Now, if this is perpendicular, we also need to find the slope of that line. And so the slope of that line is going to be y2 minus y1. So that's going to be 12 minus 0 over x2 minus x1, which is going to be 6 minus a -2. So that's going to be 12 over 8, which is 3/2. So the negative reciprocal of that is going to be -2/3. So I'm going to go down to the right 3. I could also go up 2 and to the left 3. And so there, oh, that's horrible, is my perpendicular bisector. And so far, what I've got is I've got y equals -2/3 x. And now the question is, how am I going to find that y-intercept? And so if we have our y equals mx plus b, we can take any of our points. I see a point on 8, 2. So everywhere I see an x, I'm going to put an 8. Everywhere I see a y, I'm going to put a 2. And I know my slope is -2/3. So that's going to give me 2 equals -16/3 plus b. I'm going to add 16/3 to both sides. And 2 is 6/3. So that gives me a y-intercept of 22/3. So y equals -2/3 x plus 22/3. And there we go. A little under 9.5 minutes, Chapter 6, Section 1.